Hey Algebra 1, it's me, Mr. Otto, your teacher. A geometric sequence is where we have a pattern formed by a common ratio, or maybe we'd call it a common factor, depending on which way you're going. If you look at a list or sequence like this one and you're asked, what's the next term, a great way to check that sometimes is either it's a common difference, which in this case it is not. 12 minus 4 is not the same as 36 minus 12, so I can't just keep adding. But instead, what if I take this term and divide it by the previous, right? 12 divided by 4 is 3. 36 divided by 12 is 3. 108 divided by 36, if you check it on a calculator, it's 3. So when you think of it going this way, I'm multiplying by 3 every time, right? And if I multiply 108 by 3, I will get to my answer. If I was asked what's the common ratio here, you might be confused because it gets smaller, and then it gets bigger, and then it gets smaller. But let's just use the same format. Negative 50 divided by 250. What's this ratio? I'm just going to use, well, I could tell you what it is, but let's just do 50 divided by 250 and turn it negative. So 1/5, 0.2, 1/5, negative 1/5. Then if you divide a negative by a negative, it becomes positive. In this case, positive 10. Then it goes negative again. So that's what's the interesting thing about having a negative constant factor. Negative 2 times negative 1/5 means I'm going to end up with a positive 2/5. Notice the gap between term and the previous term is narrowing. So these are called geometric sequences where there's a common ratio that forms the pattern. If you multiply, not add or subtract, but multiply the same ratio each time, multiplier each time, factor, you get the next number. To find an nth term, right, so whatever number they ask, whether it's the 9th, the 2nd, or the 100th term in what we call these geometric sequences, you're going to use the formula from page 706, or I have it copied down right here, where, okay, the position, the value of the number at that position can be found with the first term is A. That's what A means, is first term in the sequence. You need to know that, so you know where we're starting. It needs to have a base point. Times R is that rate, that ratio we talked about, to the exponent of the previous, whatever the previous term is. So let me show you what I mean. Here's a sequence where, what if we want to know what the 9th term is? The value of the 9th term is how I do that. Is, well, first term is 17. We need the ratio yet, but we know the exponent's 8 because it's 9 minus 1. So what's the ratio that goes here? 8.5 divided by 17. You with me? Ooh, that's nice. 1/2. 1/2 to the 8th. Do I have exponents on here? That only has square. So let's exponent calculator. In case you don't have one at home, you can see how I find mine. And we're doing 1/2 to the 8th. Now that I have that value, I can multiply it by the first term. Now, if you don't have a fraction calculator, this isn't a super useful answer. The book will prefer us using fractions. So now we won't use a calculator. Let's see what that looks like. We want to do 1/2 to the 8th. So 2 times 8, no. 2 to the 8th, right? Yeah, you can't just do the base times the exponent. That's not the rules of exponents. So we have to actually think about what's 1/2 times itself 8 times. Or I can just go into my calculator and do 2 to the 8th. Oops. 256. All right, so what do I do with that? That means that the value of the 9th term is 17 times 1 over 256, right? So 17 over 256 equals 9a. Well, the value of the 9th term, so that's my answer. This is where you stop. Okay? We generally will use decimal when they use decimal, but they used fractions in that case, so I should have used fraction right away. Take a look at example 4. We're bouncing a ball. It says a ball's dropped from a height of 2 yards. Okay, it's dropped. The height of each bounce is 85% of where it was previously. So the common ratio would be 0.85, wouldn't it? And so on and so forth. So the ratio here is 0.85. And what if they wanted to know, where is it on its 10th bounce? Okay, that's my n. What is the value at the position of 10? So the exponent's 9. All good so far. A is the tricky part. You're tempted to put 2, right? Wrong. It's the 10th bounce. So the first one is the first bounce, right? If I was to list bounce number 1, bounce number 2, then what's the first bounce? If it started at 2 yards, 2 times 85% is, after the first bounce, it was only at 1.7 yards. Okay, so that's the A. That's what you're going to get wrong on these if you're not watching this. My guess. Okay, now we need to do 0.85 to the 9th. They use decimals, so I'm going to use a decimal calculator. 0.85 to the 9th comes to that beautiful number. Multiply by the A, or first bounce. Approximate, let's always round to the 100th place, so 39 hundredths of a yard. Very low at that point, but realistic. Okay, that's the value of the 10th bounce. Cool? Why don't you try A, C, D, F, I, and J?